Hi, I'm Trevor, and I'll be showing off the key value store with transactional capabilities that I made called OttoDB. So to start the demo, I'll start up OttoDB. It's running on port 8080, and if I start up a session, if I connect to the database, I can do some simple things like I can set a key. Oh, yeah, I can set a key to a value, and then I can also get that key. I can delete that key, so then if I try to get it again, it will give me a null string. And so those are some of the basic key value store operations that you can do. You can do some others for transactions, which I'll be getting into because a large part of the project was making AutoDB serializable. So let me do a little demo of that. So let's say I want to show that you can't do a dirty read in AutoDB. So let's set Trevor to cool. So now when we get Trevor, it's set to cool. We start up another session, and then in a in progress transaction, we'll set Trevor to lame. And so now if we try to get Trevor, we'll still get cool. We can't read that uncommitted value. But if we commit it and we try to get Trevor again, then we get that because it's been committed. So the sort of different side of that is showing that you can't do a dirty write. So let's say we want to set t to tall. And then in a transaction here, let me set t to tomato. And so in this transaction, that set t to tomato happened while this one was in progress. So if I try to set t to, let's say, tango, I'll get, it'll abort because I can't overwrite another value. I can't perform a dirty write there. So now, showing a little more complicated transactional error that can occur is a write skew. So a write skew is when you have two values that are being updated, and even though you're not updating the same value, you can break serializability. So to show that, let's say we have two doctors and we have this on-call value. We have John on call set to true, and we have Mary on call set to true. So now both of these doctors are sick and they want to start a transaction to call off work, but there needs to be one doctor on call, so they will first check to see if the other is on call. If they are, then they'll set themselves to off call. And if both were able to pass, this would leave the database in an erroneous state. So to show this off, I'll begin two transactions, and then let's say we want to get John on call. Okay, we see that it's set to true. Okay, John on call set to true. We want to get if Mary's on call. That's set to true as well. And so Mary's saying, oh, John's on call, great. Well, I can set Mary on call to false. And then John is thinking the same exact thing. Mary's on call. Well, I'll set myself as false. But that would break serializability, so that transaction aborts. And so now, if I commit this, we get John on call. He's still on call, but Mary is also on call. So to show, that's pretty much all I have to demo for the transactional side of things, to show the sort of like restart, bringing the database back up into the state it was in before. I'll quit my connections, I'll kill AutoDB, and I'll start it back up. And so now if I connect again and I get John on call, it's set to true. If I get Mary on call, it's set to false. If I get Trevor, it's set to lame. So we've preserved all of those key value pairs that we set, and that startup, sort of like replaying the log, will filter out any aborting transactions. And I think that's pretty much it for the key value database. Thank you.